All right, so I said I was going to do one more, slightly more advanced recursive formula problem. So it was actually hiding under the blinder here. This one's a little different. Let's get rid of the blinder. Oop. So this one's a little different because it actually references more than just the term before it. It references two other terms that came before it. So notice that they want me to find a sub n. To get it, I need a sub n minus 1 and a sub n minus 2. Now remember, these are the counters. So to get term n, this means I need the term before it, and this is the term that's 2 before it. So for example, if I wanted term 12, I would need term 11 and term 10. So I need the two terms that came before it. The problem with starting this off is, say I want term 12. Well, I don't know term 11 or term 10. But eventually we go back far enough where they do give me two of the terms. So to start this off, I need two terms, because basically two terms are necessary to calculate the next one. So notice that they actually gave me two freebies. They gave me term 1 and term 2. Now, the goal was to calculate the first 5 terms. I'm going to calculate a little more than the first 5, but just to show the first 5, the good news is I got two freebies, so I just need term 3, 4, and 5. I only need to do 3 calculations. Remember, this here is just a technicality. Since they gave me term 1 and term 2, I don't need a formula for them. The formula is good for after term 2. For any number bigger than 2, like integer, term 3, term 4, term 5, we can use this formula. So this formula is valid for terms bigger than 2, because I already know 1 and 2, and I don't need a formula for these. All right, so how am I going to get the next one? Since they gave me term 1, which is 1, and term 2, which is also 1, so they're the same number there. You could have the same number in a sequence. You can make any numbers you want. So the way I'm going to get term 3, according to this formula, is if I want term 3, so a sub 3, I need to do a sub 3 minus 1 and a sub 3 minus 2. 3 minus 1 is the second term, a sub 2. And 3 minus 2 is the first term, a sub 1. So basically, to get the third term, a sub 3, I need the second term, a sub 2, plus the next term, a sub 1. So a sub 3 is going to be a sub 2 plus a sub 1. The good news is I know a sub 2 and a sub 1. They gave it to me. A sub 2 is 1, and a sub 1 is 1. So really, to get the third term, I need to add together the two terms that they gave me. 1 plus 1 is 2. So I'll show that work on the back board. I calculated the first 5 terms, actually went a little further, because this sequence is kind of famous. I'll tell you about it after we look at how it was calculated. So just to show you the work, and for term 3 and term 4 it was a little more explicit. Term 5, term 6, I started to shortcut it just a little bit, because it gets to be a lot to write. So remember what this means. If I want some term, I need the term before it and the term that's 2 before it. So the first term I can find is the third term, because if I plug 3 in here, 3 minus 1 is 2, and 3 minus 2 is 1. So to get the third term, I need the second term plus the first term. The good news is the second term and the first term are given to me. They're right here. Here's the second term, and here's the first term. So if I want to get the third term, I'm going to take term 2 plus term 1. 1 plus 1 gives me 2. So now if I want the fourth term, I need the 4 minus 1th term, or third term, and the 4 minus 2th term, that's funny, which is 2. So the fourth term is the third term minus the second term. Well, I know the third term, I just found it, it was 2. And I know the second term, they gave it to me, which was 1. So 2 plus 1 is 3. Now, I shortcutted it a little bit, because to get the fifth term, I basically need the one before it and the one that's 2 before it. So to get the fifth term, I need the fourth term plus the third term. Well, I know the fourth term is 3. I just found it. And I know the third term. I found that before, 2. So notice the last 2 are feeding in. These 2 feed in and give me 5. So then to show you the sixth term, I know I didn't say to calculate, but might as well keep it going. To get the sixth term, I need term 5 and term 4. Well, I have term 5 and term 4 here, so I add them together. So that gives me 8. So this sequence, 1, 1, 2, 3, 5, 8, this actually gets a famous name. There was an Italian mathematician named Fibonacci, and they called this the Fibonacci sequence. It actually appears in a whole bunch of places. lots of mathematical things, and then things outside of mathematics, like growth formulas. I think one of the things Fibonacci did is was able to predict if you had some rabbits, say you had two rabbits, you were able to predict how their population would grow. It would grow according, basically very close to this sequence. So if you ever see the sequence, I say go on math, this is called the Fibonacci sequence. Basically, the way you get each term, so how am I getting the 2? I'm doing 1 plus 1 gives me 2. Then I'm doing 1 plus 2 gives me 3. And then I'm doing 2 plus 3 gives me 5. And then 3 plus 5 gives me 8. So the way I get the next term is 5 plus 8 would give me 13. And 8 plus 13 would give me 21, and so on. So this pattern was you get the next one by taking the 2 that came before and adding them together. And you can create this sequence that goes on forever. This is the mathematical way of formulating it, because this is determined recursively. The way you get the next term is to add the 2 before it, and that's what this means mathematically. So this example is a little more advanced, but it shows you how you can use recursive formulas, and you can have more than one recursive thing in it. So realize this is different than the explicit. In the explicit formula, you have the n and you just plug in the n. You don't have an a sub n, you just have the n. In a recursive formula, the n's being plugged into the counter. Instead of giving you the value, it's giving you the term number you need to go back to, and you need to replace it with its value. So this is why it's very important to understand the difference between the counter and its term, what number it is in the list, versus what number it actually is. So, like a sub 4 is the 4th member of the list, but its value is 3. So you have to be able to go back and forth between that. If you get that idea, these recursive formulas aren't even that bad either. So basically, that's doing explicit recursive formulas, and you got this little more advanced example with that famous Fibonacci sequence. All right, that ends this. The next lesson will be about evaluating something called a series. A series will basically we'll be taking these sequences and adding them up. So more on that in the next video.